parabolas that open left and right. And we're not learning, it's not a new target, it's the same stuff. It's just that instead of everything being up and down, now it's all going to be left and right. Okay, so instead of the axis of symmetry being a vertical line, x equals, now it's going to be a horizontal line, and it's going to be y equals. And instead of calculating an x-intercept, we're going to calculate the y-intercept. Or instead of calculating the y-intercept, we're going to calculate the x-intercept. So everything's going to be the same. We're just doing it left and right instead of up and down. Okay? So regularly, just the basic equation of a parabola looks like that, right? Well, when the parabola, that's a parabola that goes up and down. If a parabola goes left and right, it's x equals y squared. That's parabolas that go left and right. So basically, all we're doing is switching the x and the y. So it's x equals instead of y equals. The axis of symmetry is horizontal, so it's a y equals instead of vertical, where it was an x equals. Okay, we're going to calculate the x-intercepts instead of the y-intercept. And the vertex equation changes because now that we're having y, it's y minus k instead of y minus h. So the k and the h also switched. Okay? All right, so let's just do one. Okay? I can tell this is a left-right parabola because in the squared term, it's a y instead of the x. Okay? It's x equals and then y squared. So that tells me it's a left-right parabola. But I can still find my vertex, my hk. Okay, it's still hk, but this time I have to go in the different place to find h and find k. So what's h? 4, good. And what's k? 3. Because remember, it's y minus k, so it'd be positive 3. So my axis of symmetry is going to be y equals, and what's y going to equal? 3, good. Not 4, but 3. So I'm going to put in my axis of symmetry at 3. Okay, I'm going to graph my vertex at 4, 3. So 1, 2, 3, 4, 1, 2, 3. Okay. Now, I'm still going to have my t-chart, but instead of picking x's, I'm going to pick some y's. So let's say I make y 0. And that's going to give me the x-intercept. So I get 2 times 0 minus 3 squared plus 4. So 0 minus 3 is negative 3. Negative 3 squared is 9. 2 times 9 is 18. And 18 plus 4 is 22. That's kind of too big. So I'm going to pick something else. Let's pick 3. Right. Good. So if I put 3 in, I get 3 minus 3 is 0. 0 squared is 0. 2 times 0 is 0. So that all goes away, and all I have left is 4. Oh, that's a vertex. That doesn't help. Let's try 1. So if I plug in a 1, I get 2, negative 2 squared is 4. 4 times 2 is 8. 8 plus 4 is 12. That's doable. So if x is 12, so this is 10, 11, 12. Y is 1, so it's right there. And then there's a mirror image one over there. So my parabola goes there. Yes. Yeah, I was just going to say that. Good job. Yeah, but if just like we knew that if A is positive, it opens up, and if A is negative, it opens down, right? When you're talking about the x squared. For left and right parabolas, when A is positive, it opens right, and when A is negative, it opens left. Mm-hmm. That's the vertex form. Standard form is ax squared plus bx plus c. Yeah, that's in standard form, and not in vertex form. Yeah, yeah. Okay? So far, so good? Yeah, you could, but if all you're doing is graphing, it's almost easier just to have it like this, you know? Like, if you're doing more with it, it's easier to put it in standard form, but if you're just graphing, since the vertex is already there, it's almost kind of easier to leave it there. Okay, and then let's do one more. Let's do, oh, I really want to keep doing the up and down. Let's do x equals 2y squared minus 4y plus 2. Okay? Take a second, calculate the vertex, axis symmetry, and graph it. And the x-intercept. You just run the answer there. Okay? So are we okay? With left and right, it's really no different. It's just you're dealing with y's instead of x's. Okay? So now let's talk about the focus and directrix. I don't know if we do that in Algebra 2. Do we do focus and directrix? Okay. Oh, okay. 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 All right. Well, the focus and directrix are the way you form a parabola. Because if you remember the definition of a circle is all the points that are equidistant from one point. Like if you have this one point, the circle is made up of all the points that are the same distance from that point, right? And that makes a circle. Well, a parabola is all the points that are equidistant from this focus, but if I didn't have anything else there, wouldn't I just end up with a circle again, right? So what I have tugging the parabola open is that a parabola is equidistant from the focus, which is this point in here, and a directrix, which is this line down here. Okay, so this distance is the same as this distance, but this distance, it doesn't really look like it, would be the same as that distance from here to here, the same as from here to here. I'm not drawing it very well, but like there to there, maybe more like that to there. I don't know. Anyway, I took time and measured it on this one. It looks better. So the points on the parabola are the same distance from the focus and the directrix. So do you see how it kind of pulls the parabola open, keeps it from being a circle? Because these points, as they go out here, they have to be the same distance to the directrix. They can't continue to be the same distance around the focus. And we call that distance between the focus and the vertex, and between the vertex and the directrix, we name that P. It's the letter P stands for the distance between the focus and the vertex and the directrix and the vertex. So the distance between the focus and the vertex and the directrix is equal to P. And they're always the same. Okay? The distance, this P and this P are always the same. So this P and this P are the same. This P and this P are the same. Okay? So again, the definition of a parabola is all points on a coordinate plane that are the same distance from a focus and a directrix. Okay? So if you tell me the focus and the directrix, I can figure out where the rest of the parabola goes. Okay? And I just wanted to mention too, it works exactly the same way left and right as it does up and down. I'm not going to spend time doing both just because you do the same thing. Okay? All right, so let's throw in a little algebra here. All right. So the way they came about this equation, or learning about the distance of P, was they said if the distance from the focus to a point on the parabola, so they called this xy, and they said the distance between the focus and xy is the same or is equal to the distance between the directrix and xy. Does everybody see that? It's true, right? Okay. So because we're measuring distance, we can use the distance formula. So they plugged in all the variables into the distance formula. They said if this point is 0p, this point down here would have to be 0 negative p because they're the same distance. So if this is from here up is p, from here down be negative p, right? So they plugged the points into the distance formula. So they did x minus 0 squared plus y minus p squared equals, and then x minus x squared and y minus negative p squared. Minus negative p would be plus p, right, squared, right? So they plugged in 0p, xy, and x negative p into the distance formula, right? Then the rest of it is just algebra to clean it up. So they said, well, x minus 0 is just x squared, because you subtract 0, you get x squared. And then y minus p stays y minus p squared. But x minus x is 0, so that whole thing becomes 0, and then y plus p squared. Okay, then they took the y minus p and the y plus p, and they FOILed it. Because remember, we did this when we were doing perfect squares. Y minus p squared is the same as y minus p times y minus p, right? Isn't that what squared means? Take that times itself. So if I FOILed that out, I do y times y is y squared, and then outer, negative p times y is negative py, inner, negative py is p times y is negative py, and last, negative p times negative p is positive p squared. So what I end up with is y squared minus 2p, because those can combine, plus p squared. And over here, I did the same thing, only with y plus p. I get y squared plus py, 2py plus p squared. Okay? Everyone with me so far? No? Yes? Okay. All right, then I solve for x squared. Okay, just like for algebra, I just want x squared by itself. So I'm going to subtract y squared, add 2py, subtract p squared, right? And whatever I do to this side of the equation, I have to do to that side of the equation. So I subtracted y squared, added 2py, subtracted p squared. Okay? And when I do that, it cancels out a whole bunch of stuff. These all three get canceled. That's why I did it. But it also, over here, these two get canceled, which leaves me with x squared equals 4py. Okay? And if you think about that a second and put it in regular old terms of it, we usually have y equals, right, with the x squared on the other side. So if I wanted y by itself, what would I divide by? 4p, right? So I get 1 over 4p equals x squared. Or not equals x squared, times x squared. Okay, so what do we call that number in front of x squared? Just in a regular formula, what do you call it? A. That's equal to A, isn't it? So if I rearrange that formula a little bit, I get that P is equal to 1 over 4A. Okay, and that all that State of Ohio says, you need to know how to do that, but all of that, or you need to have seen it once. Mr. Rutherford and I just decided you don't need to do it, you just need to see it once. We did all that to come up with the fact that the distance between the vertex and the focus, or the vertex and the directrix, can be found by doing 1 over 4a. And that's the part you need to be able to use going forward. Okay, you need to know that to find the distance between the focus and the directrix, or the focus and the vertex and the directrix, you take 1 over 4 times a. Okay, so in, like, let's say this equation, okay, first I'd have to find the vertex. How would I do that? Right, what's the opposite of B? All right, I think all we'll get to today is the top 2 on the homework. Just do the top 2. It's graphing left and right. Can you pass them behind you? There's 2 there. There's like a couple there. She's got a couple. Huh? Yes. Oh, okay. Just the top 2. I'll probably be here at least an hour. Did that help with the graphing? Is it better? Yep. Oh, cute shirt. Did you get yours, Ian? Okay. Oh.